Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, Accelerating the Path from Data Science to Production AI, brought to you by our friends at Tecton. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to discuss practical strategies to help you move from data science prototypes to AI solutions ready for production. Deploying AI effectively can be challenging, with obstacles like organizational resistance, technical limitations, and the risk of technical debt. In this webinar, we'll learn best practices for overcoming development roadblocks, improving collaboration between teams, and streamlining workflows for faster results. We'll also explore tools and techniques that speed up deployment while maintaining strong governance, low latency, and high reliability. We're honored to hear from a distinguished panel of experts today. Kevin Stumpf, co-founder and CTO of Tecton, Supriya, Vice President and Head of Data Science and Advanced Analytics at BBBO, and Melissa Sousa, Corporate Director of Data and AI Strategy at Emory Healthcare. Before we begin, a few housekeeping items. First, to make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the webinar. We'll be addressing your questions throughout the webinar, so be sure to upvote the questions you'd like the panel to address. And finally, to learn more about how to close the gap from data science to production AI, check out the call to action below throughout the webinar from our sponsor, Tecton. Now, without further ado, I want to welcome our panelists to the stage. Welcome, Supriya, Kevin, Melissa. So thank you all for joining us today. And then we'll start with a quick disclaimer that the views of the panelists are their own and don't necessarily reflect the views of their respective organizations. So I want to welcome all of you. And we'll start with some quick intros. Just if you guys can keep it to 30 seconds or less. Just tell us a bit more about yourself, your role, your organization, what you guys are working on. So why don't we start with you in the order that you appear on my screen. So we'll kick things off with you, Supriya.
Hi. Thanks, Brian. Hi, everyone. I'm Supriya, and I am leading the data science and analytics practice at Omnicom. It's a BBBO company, and it's a marketing agency. And here, my role is to make sure that I help clients make informed decisions backed by data science and analytics. In terms of my role, and I handle all kinds of clients, starting from telecom to retail to restaurants, hospitality, so you name it. But very excited to be here and collaborating and exchanging views on this topic today. So thanks, Brian.
Thanks, Supriya. Welcome. Melissa?
Sure. My name is Melissa Sousa. I'm the Corporate Director of AI Strategy at Emory Healthcare. I am currently responsible for identifying, valuing, and tracking the ROI of our AI use cases, designing and helping staff up our AI organization, assessing, managing our AI vendors and partnerships, and leading ideation, development, and scaling of AI solutions. We currently have 2 major AI solutions about to go into production that I'm responsible for the teams delivering. Prior to that, I worked in consulting for several years at first Accenture Strategy, where I worked on leading AI and analytic strategy projects. And then for a small boutique firm where I was the head of the Atlanta data and analytics practice, and then was named global technology service line lead. I also have worked across industries. So I'm in hospitals and healthcare now. Previously worked in hospitality, telecom, banking, insurance, consumer packaged goods, and several other industries. An early career, I was actually a full stack LAMP developer, everything from designing the pages, chopping up the images, and then building the front and back end. So got some development experience, but unlike some of the folks on this call, I'm actually excited to hear more about the technical angle of bringing AI into production, and happy to bring my view from the strategy layer.
Excellent. Welcome, Melissa. And Kevin.
Nice to meet you all. I'm Kevin, co-founder and CTO here at Tecton. It's a startup that's been around for 6 years now, and we work with both startups and Fortune 500s across verticals like fintech, insurance, and retail to help them put production AI applications into production systems, such as to detect fraud or anti-money laundering, or to make decisions as to whether they should give out an insurance to someone or not, and what the price should be, or what products an e-commerce retailer should recommend really to their end users. And before starting Tecton, my co-founders and I, we were over at Uber, where we built the central machine learning platform team that helped the organization put machine learning and AI really into every single user-facing and back office-facing facet of the company to predict the ETAs that you still see whenever you open up the Uber application, or to show you recommendations of restaurants and Uber Eats, safety predictions, pricing predictions, etc. You name it.
Excellent. Welcome, Kevin. Great intros to all of you. So excited to get started with a great conversation here. So the first thing I want to focus on, just high level, is to talk about some of the common barriers that slow the transition from POC to production grade AI. So it's a unique challenge. It's one thing to build an AI application in a proof of concept manner, but then to deploy that at scale across an enterprise, you run into organizational challenges, technical challenges that maybe were not present at the proof of concept phase. So what are some of those challenges? And let's just kind of start there. What are some of the common cultural and technical and other barriers? Kevin, why don't you kick us off there?
Yeah, happy to. Ultimately, I think things come down to the fact that once you go from prototype to production, things get serious. Like, it's suddenly now things have to actually work. There need to be SLAs that need to be met, meaning that the system typically cannot go down anymore, or cannot go down for a long time. Or if there is an issue with your system, with your AI application, such as the system that you use to detect fraud on a credit card that's being swiped somewhere, or the products that you're recommending to folks on your website, if those systems go down, somebody needs to be on the hook. Like, somebody needs to be alerted to jump onto the issue to immediately fix it. And those SLAs and this really the seriousness makes it significantly harder to put an AI application actually into production and have it interact with your end customers, with your end users, than just having a data scientist hack something up in a notebook, which they can just do on their laptop, can do in a Jupyter notebook, and it's not up and running. It's not really powering an end user, and therefore nobody's really on the hook, and things aren't quite serious. Of course, like, as things get more serious, there are a ton of different organizational and technical challenges that I think we'll go much more into in the common questions and the remainder of the session. But high level, that's what it comes down to. Things get serious, and somebody needs to be on the hook for it, and it needs to be set up in a very stable and robust way, given that things now actually affect an organization's end customers.
Yeah, great points. Melissa, what do you see in your role?
I'll agree first with what Kevin said. A lot of what we're looking at as we're moving into production with some of our Gen AI solutions that we're deploying. What is the support model? Tier 1, Tier 2, Tier 3? How do we make sure that the pipelines are going to be running consistently and effectively to feed the data into the AI models, so that we're constantly working with an updated RAG pipeline? That's the sort of thing we're dealing with. What we're also dealing with, though, is reproving the value and the accuracy. When we're doing it in the proof of value stage, like we've been in for the last couple of months with a couple of ours, we do a little bit of testing. We think the accuracy is there. We do a little measurement to figure out, okay, how much money is this going to save us? How much time is it going to save us? Is it going to save lives? In healthcare, that's something we're looking at. But the pause button gets hit right before go live, because people say, are you sure the model's accurate? Sure, it's not going to hallucinate, especially as the use case risk gets higher and higher. In other organizations, it might be risk of money, but in our case, especially when lives are on the line, people are afraid to take their hands off the wheel. So I think one of the biggest challenges is, how do we prove the ROI? How do we prove the accuracy? And how do we continuously monitor both, so that we deploy slowly and then very quickly ramp up and continue to maintain the trust of our stakeholders while we do so?
Yeah, great points. Continuous monitoring is something we're hearing over and over as one of the keys to effective implementation. So great points, Melissa. Supriya, what are you seeing?
I think great points from Kevin and Melissa. I think I would like to take a little back step as to people who are starting on the journey of AI and looking at how to get into productionalization of that. I think, Brian, at the start of this question, you said organizational and technical challenges. So in organization, and somewhere I totally resonate with Melissa in terms of our organizations sometimes fall into the trap of operating in silos. So making sure that our stakeholders who are ultimately going to be using those AI products are with us on that journey. So having them as part of the journey becomes a very important thing. And second is that we align with them on the goals. We make sure that we are sounding out that, hey, is it resonating with you? Is it achieving what we have set out for? In terms of the technical side, I think limited infrastructure readiness is where some organization falls, and making sure that we have all the tools, platforms, everything required to make sure that model that we have built goes into the production and is up and running. And then sometimes also the part of infrastructure is slow data pipelines. So again, making sure that we are scrutinizing the platforms that are required for us to send the model into production. So these are a couple of things that comes to my mind when it comes to common challenges.
Yeah, great points all around. So the next question I want to get to is on this emerging concept of tech debt. There's been a lot of discussion around this concept as it relates to AI projects in particular. So for those in the audience not familiar with this term, tech debt or technical debt means the additional work that's required to fix shortcuts and compromises that are made during development. And this kind of debt can accumulate quickly in AI projects, particularly in ones that are not thinking long term, that are just thinking we've got to get to production as quickly as possible. So as a leader within an organization, what are some best practices for reducing this tech debt during the AI lifecycle, especially as you try to move quickly from models that are in prototype or POC into production? So let's go in reverse order this time. Why don't we start with you, Supriya?
Certainly. And I love that this whole term tech debt. I think this is the newbie in the market right now, but very important one, because standing up an AI model is a costly affair. A lot of resources, a lot of investments in terms of the infrastructure is required to stand one single model. So making sure that we are not really becoming a cost center in the organization, rather than making sure that we are cost effective. So there are some things that you can do to make sure that your debt is less on the company. Number one is make sure that you are using reusable code bases. Open codes and open source codes are something that every organization goes for. Test it out, of course, and then also making sure that we are establishing coding standards. So not every time your developer is developing a code and then someone else comes up and rebuilds it. So make sure that we reduce this redundancy. There is a coding standard. And last but not the least, investing in robust version control system. Make sure, because again, this is people come and go, and this is the right reiterative process. But make sure that we invest as an organization, we invest in robust version control systems. So these are a couple of things that I think can help reduce tech debt.
Great points. Melissa, what do you find?
First, completely echo you right spot on with version control, development standards, and documentation. It's still important today, even though we, especially developers, hate doing documentation. The good news is AI can help with that. You can get a lot of documentation automated, or at least started with AI nowadays. So I think sticking to those development best practices that existed before the advent of AI for all software development needs to be there. I completely agree. I would say a couple of other things we're looking at. One is designing to pivot. So models are changing. Every time we turn around, we're doing a lot in Gen AI. So apologies if I'm referring mostly to AI in that space. But the next version of Claude comes out, and somebody says, well, why don't we try that? So we're looking at containerizing our solutions to be able to pivot them between, for example, Azure and AWS, and we're building them that way to begin with. We're requiring our vendors to do it so that we can pivot. It helps us maintain cost efficiency and effectiveness. If one of the AI vendors jacks up their rates, we need to be prepared to move that solution and test out other models, and look at downgrading models too, as versions keep going higher and higher, and they might be more than we need. So we need to be prepared to make those pivots from different cloud providers as well as different model developers. One of the other things I would recommend is one of the last things that get prioritized in data science as well as AI projects, but is the most critical, is data quality. And a lot of times when you're first building a POC, the data scientists will go in and do all the data cleanup that they need to do, and impute values and do all those things that they need to do to get the model working. And that works temporarily, but if you really need clean data sets, you need to go back to the source systems. You need to identify the source of data quality issues and resolve them. So I recommend as you're coming out and choosing which use cases to try to go to production with, choose use cases that you can get people behind to clean up the data quality up front, because that data is valuable for more than just the use case you're working on. That way you can build the pipelines you need, the data quality fixes you need up front. Whether your AI solution gets deployed or not, it's useful to the organization for other use cases, and you'll get support for doing it the right way the first time.
Yeah, excellent points, Melissa. Kevin, your thoughts?
Yeah, to add to all the points that were just made, first thing I'd love to just super briefly define, what does tech debt actually really mean, or what's a symptom if you have tech debt? And what I primarily think about is if a system has a lot of tech debt to it, then it typically means that it's extremely hard or potentially even impossible to make changes to that system or to debug any issues that you have with that system. And so as a result of that, things are just way more inefficient than they need to be. And that's typically a common symptom of a system that you've built that has accumulated a ton of tech debt. And that's why it's extremely important to not let too much tech debt, if any, accumulate, because you want to be able to be nimble and iterate quickly and make changes. And if issues happen, debug them very quickly. And so tech debt is bad. And to fight tech debt, I think about three different pillars, if you will, that come together. One is standardization. Second is centralization, and then the third is automation, really in that order. And standardization just means, okay, folks follow a common best practice, which was mentioned beforehand. And that could be things like, okay, we should be using version control. We should be reviewing pull requests. We should follow a standardized system to measure the data quality and the quality of the model performance. Things should just be standardized. And why is standardization important? It's important because it makes it easier for another human to jump in and look at whatever someone else has implemented and see, okay, do I agree with this? Is this a good idea? Or it makes it easier for them to actually take over a project. And if things aren't standardized, then it's very hard for people ultimately to collaborate with each other, because if everybody just does their own hacky, wacky thing, it's just harder for others to learn it and ultimately collaborate. So standardization, I'd put first. And then second, if you've standardized things well, I would move to centralization. Having potentially a centralized team of experts who look at every pull request that actually goes out into production to make sure things are actually implemented a correct way that's in line with the company's standards and best practices. Because again, centralization allows you to really, if you will, enforce standardization and best practices and put some people behind it who are the experts behind it. And then finally, the third thing, which you can most easily do if you've got centralization implemented, is automation, which means now that you've got a centralized system that follows best practices, you can actually more easily implement automation, such as automatically rolling out a new version of your machine learning model or for your AI pipeline or for your feature pipeline or whatever it is. And that now comes with incredible speed up benefits, because anything that you can automate, you don't have to manually implement, of course. And for instance, back in the day when we were at Uber and we built the central machine learning platform called Michelangelo, it was all about automating away a ton of the typical challenges that people had to solve manually, from training a model to deploying a model to monitoring the model to implementing feature pipelines. Anything was solved by following standardized procedures in a centralized way and automating all these processes. And the last thing before I'll stop going on this point is, oftentimes when people hear centralization and standardization, they may think, oh, well, doesn't that slow things down? Don't we want to have folks be able to just run as quickly as they possibly can in a decentralized manner? And I've seen at an organization like Uber, which valued speed above everything else, that people were able to move much faster than they otherwise could have by following these centralized systems that used a lot of automation. Because here, the key to high speed and moving really, really fast was the automation aspect of it. And you may think, okay, folks in a decentralized fashion just get their prototype out in production really quickly. It's true. You can oftentimes get that prototype out in production faster than if you follow any best practices of centralized systems. but that's just the first 1% of the project. The next 99% of maintaining it, updating it, having the next person take it over, etc., is where really the rubber meets the road. And if you ignore kind of the standardization of things, that's when things will be way more expensive than they need to be.
Yeah, that's a great point, Kevin, that standardization is not the enemy of speed, at least not, when you think about speed of building something sustainable, right? Because that's, if you haven't built something sustainable, what's the point? So very critical for folks to think about from a cultural standpoint of kind of inculcating that in their developers. One of the things that I want to just kind of drill down on is this idea of AI, this building anything at an enterprise level in production really is a team sport and requires a lot of different folks to have input and to be able to work together in a cohesive fashion. So in particular, data science and data engineering teams are critical to deploying most of these applications in production. So what do you guys find are some best practices in ensuring those teams and other teams within the organization are working together, have great communication, great alignment about ultimately where you want to go? Melissa, why don't you start with that one?
Sure. I have a couple ideas, but I'll stick to one, and because I'd love to hear from my fellow panelists on this and see if we agree. I think one thing that I think is critical is a bit of cross-training between data scientists and data engineers so that they understand each other's work end to end. What are the types of tasks that are involved in delivering pieces of work? And that way they understand the implications of decisions that they make. So we've talked a lot about standardization or best practices, implementing those and standardizing those across the way. And if you don't know what the implications are of the hacks that you put into place downstream because you don't know what the next person's going to do with that piece of work once they pick it up, I think it makes it hard for you to judge whether those hacks or band-aids that you're developing short term are going to have bigger implications long term, create technical debt, but also just create unintended consequences down the road. So, if you create a change in an upstream process that changes the data collection methods, which then impacts the accuracy of the model that's being developed on that, which then changes the accuracy or the quality of the output data coming out of that model. It's a vicious cycle, and you can create problems that replicate themselves. And I think unless data engineers and data scientists understand those implications and understand each other's ways of working, it's going to be difficult to predict what you might be impacting. So I think that's one thing that I think is critical, is cross-training.
Great points, Melissa. Kevin, what are your thoughts?
Yeah, 100% agree with that. When I saw the question, the first thing that popped into my head was machine learning engineer, which is basically a hybrid role of data scientist and engineer. And then when Melissa made the point of cross-training, ultimately that's what it comes down to. If you take it to the extreme and you cross-train a data scientist in engineering, eventually they're a machine learning engineer and vice versa. And they don't have to necessarily be a full-blown machine learning engineer. They can just be still 90% data scientist, but 10% engineer, or 90% engineer and 10% data scientist. But having really that empathy for the other side, that's maybe not your bread and butter, or what somebody else on another team will have to pick up from you, is absolutely critical in order for people to work effectively with each other. And so to the extent that the listeners here can in their organization, I would 100% invest in having machine learning engineers or growing machine learning engineers in the organization, and then supporting them, supplementing them with data scientists and engineers who are more the experts in their respective domain, but still trying to ensure that they have some minimal level of base knowledge of what the engineering or data scientist side of the house does by investing in this cross training.
Yeah, great points, Kevin. Supriya?
I think agree with Melissa, Kevin, both, and I think now the roles are evolving, and more than evolving, it's merging. And especially with whole Gen AI coming into the play, even strategists are now accessing ChatGPT, for example. And a wonderful thing is that, at least in my organization, I actually am a part of, I don't have a separate engineering or data science team, but I am part of a strategy team. So I sit with strategists, and we are working together on it. So there is no engineers or data scientists. We are whole, when we are assigned on a project, we come together, put our brains together, bring our expertise, and then, once a project is done, model is deployed, we go, on our separate ways. But in terms of what I'm coming to is that roles are merging. We are working on more, waterfall, or you call it agile project management style, where we are actually tackling a problem or issue or product together. So that's what is happening. Another thing that, and wherever it's not possible because of the sheer size of the engineering and data science team, bring in some kind of joint accountability for metrics and outcomes. It should not just be data scientists, or it should not just be the engineers, but they should together be responsible or accountable for what the outcomes finally is coming out from the models. And of course, the famous C word, communication. So I think that is the underlying, rule that everyone should follow. Make sure that everyone is feeling participated and regular updates are being given. So certainly these are some of the best practices one can follow.
Yeah, great points, everyone. So jumping to our next question. So one thing that we're increasingly seeing in some AI pipelines is the concept of unified frameworks for batch streaming and real-time data processing. So are you guys seeing that? And how do you find that unified frameworks are helping to streamline AI pipelines if you are? Kevin, why don't you start there?
Yeah, I think that's particularly relevant for real-time AI applications, whether that's your recommendation system or fraud detection system, or maybe it's a Gen AI application like a chatbot that receives real-time information about what's actually happening with this customer who I'm currently talking to, how many support tickets has this person actually filed over the last week or whatever else it is. And typically one of the most common traps in building machine learning applications, especially predictive machine learning applications, is if you train your model on one data set that looks different to the data set that you actually give to the model when you make predictions in production. So you're training a model on a subset or on billions of rows that show credit card transactions, whether they were fraudulent or not. And when you then put the model into production, you want to make sure that the data that you serve to the model, where it's trying to infer whether this transaction is fraudulent or not, looks very, very similar to anything that you were feeding to the training algorithm when you were creating the model. So to give you a more specific example, let's say one of the features is how many transactions have happened on this credit card in the last 30 seconds, because maybe a burst of transactions on this credit card from different IP addresses is actually a pretty good signal that some fraud ring is trying to abuse the system and take advantage of it. And if you now have one way of calculating this number of transactions count over the last 30 seconds in your offline system that differs from the way you would calculate it online, then you can introduce the feared offline-online skew or train-serve skew, where ultimately your model is just not going to perform at all or not the way it could if you avoided having different implementations that calculate the data that you show to the training algorithm at training time or to the model in production time. And all of that said, how does that come back to your question of unified frameworks? Having a unified framework where you can basically define a transformation, such as this 30-second transaction count, just once with one line of code, and that very same line of code gets executed against a batch data source, like a data lake where all of your historical transactions are, or against your streaming system where your current live transactions are, is critical because it basically almost entirely avoids the risk that you're introducing this skew issue that I just mentioned, which leads to performance problems that are insanely hard to debug. And so, yeah, I'm a big fan of these unified frameworks, the open source unified frameworks out there. The most common ones are Spark and Flink. We use them under the hood at Tecton as well, which is another unified framework and platform to avoid these issues.
Yeah, great overview and examples, Kevin. Supriya, what are you seeing in this space?
Same, I think I 100% resonate with what Kevin just shared in terms of unified processing engines like Apache Spark, where it has ability to batch process through its core API, and then also streaming through structured streaming. So again, making sure that we have important transactions are being noted. For example, a similar example from financial services company, they can use Spark to process historical data for risk modeling while simultaneously also analyzing some real-time transaction for any fraud detection. So all within the same framework. So that's the talk of the town these days. And some of the platforms that has now, and in fact, most of the AI, or I would say data platforms, are moving towards that. Databricks is one, or Google Cloud Dataflow is one, or AWS Glue and Kinesis integration. So there are many players in the market, and mostly all are now going towards the unified framework.
Yeah, great context, Supriya. Melissa, any thoughts there?
I would say beyond just the framework, I think the idea that Kevin spoke about of a unified data set is important. Back in my consulting days, I had a client who wanted us to deploy a model we developed to predict what you should buy on the website and deploy that same model to the salespeople on the tablets in the store. And we realized after they had initiated the project that database powering the back of the stores was different than the web database, and the rule sets that apply to someone buying in store differ than what they can buy online. And so understanding and unifying all of that upfront and knowing where you should have a single unified data set and where use cases aren't appropriate because you just can't unify the data set, or you're just going to be working from different KPI or data definitions is important. Then on top of that, I think the unified frameworks are helpful. And especially as we look at multi-cloud, how do we modularize and segregate how we do our batch streaming and real-time data processing from the underlying cloud infrastructure that we've selected? So if we build everything in Azure and then we have to rebuild it and make it work exactly the same in AWS, what are the implications of that? And Kevin talked about tech debt and how we avoid that, and you have old pipelines sitting around over here because you moved a use case to a different cloud for cost optimization, but now you've got this debt on the other side. How do we avoid that? So we're actively researching and trying to learn more about the available tools in the market to kind of solve some of these problems.
Yeah, great points there and examples. So we talked somewhat about automation. Kevin made some great points about leveraging automation to implement the standards across an organization, but I want to just drill into that one a bit more, talk about how automation can be leveraged to accelerate time to market to move from proof of concept to production. Supriya, why don't we start with you on that one? Anything interesting you're seeing on the automation front?
So in terms of the automation, I think I'm seeing, again, similar examples in the market these days. And like Melissa said, we are also learning as to what are some of the tools that we can use for these kind of automations. And Apache Beam or Daxters, that comes to my mind when it comes to especially in terms of providing batch and streaming data processing. And again, coming from the marketing, or I'll say I'm from a marketing agency background, and how these tools are making difference to what we do. So our team, especially marketing analytics, we use Beam to define a pipeline for user behavior aggregation, and the same code process both historical logs, which is like batch, and incoming event streaming without additional complexity. So these are the kind of automation that we are now moving towards, learning more about it, learning more what are some of the platforms that are available to do that and make our data scientist job really easy.
Yeah, great point, Supriya. Kevin?
Yeah. I mean, ultimately, automation, what is it? A data scientist and ML engineer has to do fewer manual steps than they otherwise would have. And the most recent great example that I saw was at AWS reInvent, the GenAI, how they combined Amazon Q, which is their GenAI bot, with SageMaker HyperPod. And you could just basically chat with your data science environment there and entirely train your entire model from whatever data sets you have on AWS and get it in production just by chatting with it. Everything is fully automated behind the scenes in a standardized way. So that was a pretty good looking example that I saw. What I see more commonly in the real world, the gold standard of automation is, especially if you're talking about maintaining and building a production AI application that is powering your end customer's experience, to manage your system as code that your machine learning engineers, your data scientists, your software engineers are contributing to. And that code would live in your version control system like Git. And as you make any changes to it, whether that's a slight change to the data set that you want to train against, or the features that you want to engineer, or the model training algorithm that you want to use, that should all just be defined in a few lines of code in your Git repository. And as you make a change and roll that change out, you should have basically a CI/CD pipeline, a continuous integration and deployment pipeline like Jenkins or Circle CI or BuildKite, any of these systems automatically spin up really a job that now automatically trains your system and deploys your system and monitors the system. And if anything looks wacky during the deployment process, automatically roll it back. That's the gold standard that I see companies eventually get to. Everything is managed as code. Everything's automatically rolled out using CI/CD pipelines, fully monitored, and ML engineers, data scientists, they really only need to make minor tweaks, minor changes, and 99% of the heavy lifting is fully automated away for them by the automation that the ML platform team has put in place for them.
Yeah, great points, Kevin. Melissa?
Yeah, as I mentioned before, I think where we are in our journey, figuring out the automation of the evaluation of these tools is critical for us. I think a lot of our developers are old hats at CI/CD and some of that traditional automation, even though this field isn't that old, but more comfortable with the automation of the actual deployment of the code, infrastructure as code, and things like that. I think where we're trying to get our hands around is how do you evaluate non-deterministic systems like the output of a Gen AI solution. And so we're using tools like LangFuse. It's an open source LLM engineering platform where we're getting traces and logs of what's going on our large language model solutions. We can pull up the prompts, the results. We can do manual coding for accuracy. We can also track other things like latency, model latency. We can look at prompt performance, tokens submitted and used. So we're kind of using it in the background to start thinking about how do we get to a more automated evaluation platform for all of our Gen AI solutions that we're deploying. But we're looking at other vendors too. This is just our first kind of exploration into that space. And there's a lot of great vendors that are coming out. And now I'm noticing a lot are specializing in specific industries too. So we've been approached by a couple of platform vendors specifically for healthcare, looking at how to evaluate and deploy and automate large language model solutions. But we're also interested in cross-industry solutions, and it's an exciting time to be in this field because some of these platforms are just being developed and being launched. That will become, I think, the gold standard for how we do automation in the future.
Yeah, great points. I want to jump now to a few other issues that are important to production-ready AI, and that is governance, reliability, availability of data. What are some frameworks around these to ensure that these are also built into your AI deployment strategies as you go from POC to production? Why don't we start with you on that one, Melissa?
Sure. So I have 5 areas of governance, and I'm responsible for strategy and governance, my team is. And 5 areas of governance I'd say we look at holistically, and we try to think about looking at all of them in a unified way to make sure that we're governing our solutions and our processes and our ways of working. So the first is the governance of the roadmap itself. What projects and products are we letting come into our pipeline? What features are we prioritizing and why? Governance of the organization. How do we work together? We talked a lot about best practices and standards and automation. How do we do that work? And then how do we make sure that we're all staying in alignment with those standards and guidelines and best practices? Governance of the applications or the solutions. I'm separating that from the model governance specifically because this is the traditional software engineering, uptimes, page load times, those sorts of things that we need to keep SLAs and keep an eye on and make sure that we're versioning and iterating on consistently as well. And then separately, the model lifecycle and governing that. So everything from how do we select the model? So if we're looking at a Gen AI model that's out there, how do we select that? How do we monitor the performance of those during their life cycle? And how do we do champion, challenger, and other methods to determine when new models should supplant the existing ones? And then obviously deprecate our old solutions, our old models. And then finally, and most importantly, as I mentioned before, governance of the data itself. So what is the underlying data going into the model? What's the output coming out of the model? And how are we making sure that both of those stay in spec to performance our end-to-end solutions?
Yeah, great points, Melissa. Supriya?
Right. I think I'll pick from what Melissa said in terms of the data quality and basically tracking the model and data lineage and making sure that there are no biases. We are able to track the data sets. We have ability to pre-process the models. We have ability to control the versions, deployments, and also it also depends on where you are in your maturity with AI. productionization. So essentially the data quality becomes the most important, and for that data lineage tracking becomes important. Another thing is, of course, making sure that we are giving right access control to who needs it. And of course, there are several platforms that can help you, and it depends also on what cloud you're using, or what machine learning infrastructure you have, so you can control that. Another thing, and especially in my area of work where we are using a lot of client data, so client data is actually sending us data to look at. So making sure that we are aligning with the regulation. So if it is something related to healthcare, then we are making sure that it's having HIPAA in place, or CCPA or GDPR. So making sure that our clients' data is safe and secure. So compliance monitoring really becomes part of what I do. Yeah, I think these are the main that comes to my mind.
Yeah, those are excellent points as well, Supriya. Kevin, what are your thoughts here?
For reliability, the two main things that come to mind for me are, on the one side, clear ownership and observability. Observability just means, well, if something is not reliable, you need to be able to become aware that it's not reliable. And without a good observability system that monitors the data quality or the model performance, or whether pipelines are even up and running, you've already lost the battle. You don't even know when systems suddenly aren't reliable anymore. But it's not the battle isn't won entirely if you know that the system isn't reliable anymore. You also need to then know, okay, who's actually responsible for fixing it? And if you have a diffusion of responsibility type problem, then you've got a huge problem as well. And so it needs to be very, very clear who is actually on the hook for maintaining a pipeline, who's on the hook for maintaining a model that's running in production. And if things look like they're not reliable anymore, who's got to jump into it, debug it, and fix the problem. So for reliability, again, for me, it's about observability and really clear ownership. And then when I think about governance, at least in my mind, a pretty overloaded term. What do we actually mean? Like, so many different things could be governed. Is it who has actually access to the system, who's authorized to access it and discover new data or make changes to a model, or to PII data? And like, there's a million different things that it could be governing. And of course, depends on the use case. It depends on the industry you're in, whether it's highly regulated or not, etc. But generally, governance probably always comes down to, we need to be able to somehow constrain something, like an access to a system or something like that. And the best way generally in the abstract to accomplish that is, again, through some form of centralization. There should be one central way of ultimately getting your Gen AI application into production, where you can just, through this one central way, introduce a gate, really a governance gate, that ensures that all of your organization's governance criteria are met, such as, is this data actually allowed to come in here? Or is this a use case where I'm actually happy to take on some hallucination risk because it's only a chat bot that's dealing with internal employees and it's not publicly on my website, etc. And really introducing these gates that ensure that your system is well governed and complying really with the rules and regulations of your organization and industry. The best way I typically see that being solved is through some form of a centralized approach.
Yeah, it's a great points, Kevin, and really critical, I think, with all of these AI use cases as you go from proof of concept to production, is that risk assessment of, if it's wrong or if it breaks, or if all these worst case scenario things happen, what's the damage there to the organization? And those things at proof of concept, your risk tolerance might be a lot higher for that kind of thing than it is when you actually roll it out to production and it starts being customer facing. So figuring out what are those use cases and what's that risk assessment look like, and how does that impact various things like governance? Great points there. We've covered a lot of ground. Our final sort of substantive question is about balancing within an organization resource constraints. So if you're facing competing pressures where you have a need for speed, obviously cost is always a factor, and performance is a factor. So how do you balance these various different things within an organization and allocate resources in a way that's appropriate to the use case as you roll something out from POC to production? Why don't we start with Kevin on that one?
Yeah, this one it depends just so much on the use case. I mean, generally I would say start small, and for the early prototype or whatnot, I wouldn't overthink cost efficiency. And while I'm just prototyping, just see, hey, can an AI model actually help me with this problem? can I actually detect fraud here? Can I actually make good recommendations? Can I actually have a chatbot that gives good answers? Or can I generate marketing messages that actually look good? All of this prototyping should just happen in an environment where costs don't matter, because given that it's a prototype that you're just testing and developing, it's typically not rolled out yet at high scale. And high costs typically occur more at high scale. And so at the development, at least early proof of concept phase, optimize for speed before anything else. And then when I have something that actually looks like, okay, I've proven value here, I can actually solve a problem with an AI model, then I'd next look at, okay, how expensive would it actually be to run this thing in production, given the scale requirements that I have? And I wouldn't jump to what in software engineering is typically referred to as premature optimization. Like, you may not have to optimize anything. Maybe your prototype implementation as is actually pretty good, and it's not the most cost efficient thing you could be doing. But given the scale of your problem or your production system, it may not matter at all. It may not be worth the hours of labor that you would put into it in order to over optimize the system. And so, yeah, start small and then look at it and then extrapolate from what you've built that's proven value into how expensive would it be in your production system. And do you even have to optimize or not? And if you have to optimize it, then take the next steps that are pretty problem specific. Like, do you want to use a cheaper model? Do you want to use an open source model? Do you want to distill one? Do you want to fine tune one? Whatever else it may be. But that would very much depend on the use case.
Yeah, great points, Kevin. Melissa?
I think it also depends on your organization and what they value. I think in some organizations, they want to see results and they want to see it fast. Some organizations and some use cases, but some organizations as a whole have a low tolerance for a lack of performance. So unless it's 96% accurate all the time, every time, they're not even going to look at it. I find in scientific and healthcare organizations tend to apply a very rigorous standard there. And then in other organizations, they're not going to do it unless you can prove to them out the gate it's not going to cost an arm and a leg, because they see AI as superfluous or nice to have. So I think you first have to measure the temperature of your organization and figure out what are you optimizing for. I agree in the POC phase that getting speed to something you can show to your stakeholders to prove that this can be done is important. For us, we are also, though, keeping a tight eye on cost efficiency. As a healthcare organization, we're trying to keep healthcare costs low for our organization, but also for our patients. And so making sure we're good stewards of the dollars that we get from the government agencies and from our private consumers is really important to us. So we look at those two things, and we'll go slow if need be to ensure that we get good performance and cost efficiency. But that's the nature of our industry.
Yeah, very good points. It always depends on industry and organization. Those are critical factors. Supriya?
I think I don't have any new points that Kevin and Melissa have not covered, but just 3 quick things that come to my mind is that make sure that you are leveraging cloud native services, because you can choose your own tier there, using pre-trained models when appropriate. I think Kevin has already covered that. And then smart resource allocation based on the project criticality. I think both Melissa and Kevin has covered that. So yeah, I think these are the things that we should be taking care of.
Yeah, great point, Supriya. So we're getting close on time, so I want to wrap up with our lightning round. So for each of you, in one phrase or a couple, what is your top takeaway for organizations that are looking to accelerate their path from POC to production AI? Why don't we start with Kevin on that one?
Biggest one for me is, I think Melissa used the term of cross-learning. I think everything comes down to that. Like, invest in educating your team and having them see a lot more of what else is happening on the other side of the aisle, both to build empathy, which ultimately will increase collaboration, make them more efficient and faster. But besides just empathy, even learning about what other solutions are there that I've never even considered to problems that I'm having right now that could make me ultimately more effective and happier at my job.
Yeah, excellent point. Supriya?
Focus on scalable infrastructure, look at cross-functional collaboration and continuous improvement to ensure that we are, ensuring seamless integration of AI into business operations.
Great point, Supriya. Melissa, I'll give you the last word.
I'll go back to measurement. Make sure that you have designed and can measure the results of what you're doing. So to add to what you two said, because I completely agree on those as well, that if you're not prepared to measure the performance of what you're building and whether it achieves the outcomes that you're looking to achieve, getting leadership support to scale is going to be very difficult. And I think you have to have the infrastructure, like Supriya said. I think you have to have the culture and the cross training, but I think you also need leadership support and investment. And from a strategist perspective, making sure that I have all the data that I need to show my leadership that this is the path we need to be on is the most critical thing. So agree with Kevin on observability and making sure that those tools are built in the background from the beginning as part of our infrastructure.
Yeah, great points all around. This has been an incredible discussion. So I really appreciate all of you joining us today. For those in the audience, if you missed any of this webinar or you'd like to rewatch anything, it will be available at the same URL if you just refresh the page a few minutes after we conclude. And I want to say a special thank you again to both our panelists and to our partners at Tecton for making this webinar possible. So thank you all again for a great discussion, and we look forward to seeing you all next time. Thanks.
Thank you. Bye-bye.